So, what if everything you think you know about reality, space, time, matter, the whole shebang, is just plain wrong? We're about to dive into an idea so radical, it might just be the key to a theory of everything. And it all kicks off with one single powerful sentence.
Right there, that's our starting point. It's a wild hypothesis, and it basically says the universe isn't made of tiny little particles floating around in an empty void. No. Instead, it suggests the universe is made of only one thing, space-time itself, just behaving in some very, very strange and beautiful ways.
To really wrap our heads around this, we've got to challenge our most basic assumptions. So this first part is all about building a radical new reality, and we're going to start with the fundamental relationship between matter and space.
Now, this is a huge shift in perspective. We're all used to thinking of space as this passive stage, right? An empty box where all the drama of physics plays out. But this new view says, nope, space is the actor. Everything we see, from a tiny electron to a giant galaxy, is just a different performance put on by spacetime itself.
Okay, so if matter is just a behavior of space, that completely rewrites the story of our origins. So let's do it. Let's go all the way back to the very beginning and see what the first moment of the universe looks like through this new lens.
So the Big Bang wasn't some explosion of matter into empty space. Forget that picture. Instead, I want you to imagine a perfectly still, perfectly synchronized ocean of oscillating spacetime. The bang was the moment this perfect coherence just shattered, like a flawless crystal suddenly fracturing. And in that instant, the fragments of that perfect oscillation twisted up and became these self-trapped knots, and that, right there, was the very first matter.
All right, so the universe began as fractured space-time. Now let's see how this theory builds everything else from the ground up. How do these knots in space-time actually become the fundamental stuff that we know and see all around us?
So here's the absolute crucial point. A particle isn't a thing. It's what's called a topological defect. The best way to think about it is like a knot in a rope. The knot isn't made of something different than the rope. It's just what the rope is doing in that one spot. It's a persistent, stable shape, literally in the fabric of reality itself.
And mass, what is that? Well, in this picture, it's simply the energy of a vibration that's gotten tangled up in one of these knots. See, a free vibration, like a wave of light, it can just travel forever, so it's massless. But the second that vibration gets tied up in a geometric knot, bam, it has mass.
And this whole geometric idea goes even deeper. It suggests that something as fundamental as electric charge is, you guessed it, just geometry. A positive charge could be, say, a clockwise twist in space-time, while a negative charge is a counterclockwise twist. And why do opposites attract? Because their twists can line up and perfectly cancel each other out. It's that simple.
Okay, so we've built matter and charge from geometric knots. Pretty cool. But what about the really big stuff, the heavy hitters of the cosmos? Well, it turns out they fall out of this model just as elegantly.
You know, we think of gravity as this force that pulls things together. But here, it's not a pull at all. It's the universe trying to iron out its own wrinkles. Matter is a dense, twisted knot of space-time, right? Well, gravity is just the tension that's created as all the surrounding space tries to relax and go back to being smooth. Objects aren't being pulled, they're just sliding down that geometric hill.
Now this one is a real mind-bender. Time isn't a fourth dimension that we travel along. It is the fundamental pulse, the heartbeat of space-time itself. So in places where space-time is really compressed and twisted, like near a planet or a star, its oscillation actually slows down. And so, time itself slows down. It's not a trick, it's a direct result of the geometry.
So that brings us to the ultimate knot in space-time, a black hole. It's not some dead star that eats things, it's the end state of space-time itself, a region that's gotten so incredibly over-twisted that its oscillation just grinds to a complete halt, creating a knot so dense that nothing, not even vibration itself, can find a path out.
And that's the key to the event horizon. Light can't escape a black hole not because it's being pulled back by some super strong gravity, but because the very geometry of space-time inside that boundary forbids any kind of outward moving vibration. There is literally no path leading out. The door is gone.
So this is a really beautiful and consistent story of the universe, right? It all just kind of clicks. But the real power of any new theory is in the problems it can solve. And trust me, this is where it gets really, really exciting.
Get this.
This single, elegant framework, this one core idea, has the potential to just dissolve at least 15 of the most stubborn, head-scratching paradoxes in all of modern physics. Let's just run through a few of them.
Okay, down at the quantum scale, some of the biggest mysteries just seem to evaporate. You know that weird wave-particle duality thing? Well, it's just two states of oscillation, free versus trapped. Done. What about the measurement problem? A measurement is just forcing space-time to lock into a phase. Why is energy quantized, coming in little packets? Well, you can't have half a knot. And that infamous black hole information paradox? Solved. Information isn't destroyed. It just gets re-encoded into the geometry of the knot itself.
And then, on the huge cosmic scale, the same thing happens. Why is the universe so smooth and uniform everywhere we look? Because it was all born from one single, perfectly coherent state. What's dark energy? Maybe it's just the leftover tension of space-time still trying to relax from that first big fracture. And the arrow of time, why does it only go forward? Well, that's just basic topology. It's really easy to shatter a crystal, but it's almost impossible for all those pieces to spontaneously jump back together perfectly.
When you look at it this way, the universe isn't a collection of things at all. It's a single, dynamic, geometric object. And that leaves us with this final, absolutely tantalizing question. If the simplest knots in spacetime create particles, stars, and galaxies, what other, more complex geometries are still out there just waiting for us to discover them in the fabric of reality?